So we have played enough with lists and strings, and we have some sort of tools that we can depend on in order to write some more interesting programs in Python. By interesting, I mean things that we can actually put in practice and make useful programs with them. And these include conditional statements and repetition statements. A conditional statement is something that we can use to enable our program to make decisions. If something comes true, the decision is made to go inside the conditional statement and execute something. If the condition becomes false, we just neglect whatever is subjected to that condition. Now, what does that mean? First of all, before writing some useful conditional statements, I would like to point out that we have a type called the Boolean type. The Boolean type has two values, just true and false. These values are basically ones and zeros. True can be just the number one, which we can apply arithmetics on it. But how can I use this? For example, we could ask the computer to do a comparison for us. This is a comparison, which is a relational expression. We are asking, is 4 greater than 5 or not? In this case, the answer is false, because 4 is not greater than 5. We could also take two numbers from the user and make a meaningful decision here. For example, we can say x is a number from the user using the input function evaluated to be converted to numeric values. So let's say this is 4, and then y is another number that we can take from the user, and this is 8. Now in this case, we know because we are the user, we are testing our program, but when we are giving our program to people to use, we don't know what values are being chosen. So when we ask, is x greater than y, in this case also we get a false. Is x less than or equal to y, in this case we get a true. We can also apply an equality operator, which is x equal to y. Now this is obviously different than assignment operator, which is just one equal sign. We could also say if x is not equal to y, in this case the answer is true. So these are the relational operators that we can use to build truth values, which are true and false. These are computed in CPU's ALU component, which is the arithmetic and logic unit. These are used to do the basic logical operations that we need for computers to make decisions. Now, other decision-making operators are membership operators. For example, we can ask if 1 is in this list. In this case, this is true. We could also ask if A is in this string. This is also true. We could reverse this and say not. For example, we could say 1 not in 2, 3, 4. In this case, this is true. We could combine multiple logical expressions using and or connectors. For example, we could say if x is greater than y and 1 is greater than 2. This is obviously false because x is not greater than y. This is enough to deduce that this operation yields a false value. Now we could reverse that. If x is less than y and 2 is less than 3, in this case we can get a true. Or we could say x is less than y or 1 is greater than 2. So it's enough that one of these two becomes true, so we can get a true at the end. These are the expressions that we can use to build the conditional statements that we need. Let's write an interesting program. So I'm going to switch to the Visual Studio Code, which I mentioned in a previous video. Here we can create a new file. so that it can carry our program. Let's say conditional one.py. The .py extension means that this is a Python file. So here in this program, we're going to ask the user to give us a number. What we want to do is to produce the square root of this number, which is either using the square root function from the math library or raising it to the power of half. Now we know that the square root becomes complicated when we have a negative number. So the square root is not defined for ordinary numbers here. We want to prevent computing a square root for a regular negative number. To achieve that, we will have our program check the input that was provided by the user. We could say if x is greater than or equal to 0, meaning that the number is not negative, then the square root would be x to the power half. Otherwise, we want to say that the square root is undefined. Okay, we can run this program to see what happens using the command line. So if you are using Mac or Linux, you can just call the Python interpreter to run your program. The program's name is conditional1. Now it waits for our input, which is going to be 4, and the result is 2.0. We can try a different number, which is -4. In this case, the program results in an undefined message. What have we done here? We have written a conditional statement, which is called the if statement. The if statement comes with a condition. This is the condition part. Anything that results in a true or false can be written here as the conditional expression. Then it has to follow a colon here so that the syntax is correct. And then we'll have to have an indentation here and then write any statement that is subject to that condition. So in this case, we want to make this print statement conditioned to this condition here. So if this is true, this will get executed. Otherwise, it's just neglected. Now, if this is not true, which is false, the else statement will be executed. Now, else has no condition here. This just means that otherwise. So either this print statement or this one get executed by the computer depending on the value of x. Is an else a necessary component of every if statement? No, we could have just an if statement and make the statements beneath the if statement subject to the condition, and then provide no otherwise option. In this case, we needed the otherwise option to inform the user that we are not able to compute the square root. Another example of using conditional statements is a checking before actually converting the input to a numeric type. We know that the eval function uses the value from the input function, which is a string, assuming that the string has numeric values in it. It will try to convert the type of that value into a numeric type and store it in X. Now, if we want to prevent problems that can happen from mistakes by the user, for example, let's see one of the problems here. If I, by mistake, enter 4 and then an A, there will be a runtime error here because the eval function is unable to convert this value to the numeric type that we want. 4A is not something that we can convert to integer or a float. So what we can do to prevent that? We can first remove the eval part from the input function. So we're just getting a plain string input. We could also supply a prompt message for the user, enter X, so that the user is informed about the input part. Now we want to make sure that if X is not something that we can convert to a numeric type, we just don't go ahead with the eval. If it is possible that we convert x to a numeric type, we can use the eval function. So we can say that if x dot is digit, then we can say x eval x. Otherwise, we have to do something about the rest of it. So we can go ahead and continue with the rest of the program to be inserted beneath the if statement here, so that the rest of the computation depends on whether x is a digit or not. And then we can have another else here to say that unable to compute the square root. Okay, if x is something that is not a digit, then we cannot have a way of knowing what is the square root of the input we received. Let's test our program here. We can clear the commands and say this is for a, and then we get this message here, which is the result of this else here, which is the opposite of the value of this if statement. So if this was true, then we wouldn't get this message here. So how about for? Then we are okay. This condition passes and this condition passes, and then we get the result that we want. How about, say we want to compute the square root of a real number. How about this? Now we get the message that says unable to compute the square root of this number, which is 4.5. Now why are we getting this? Because 4.5 will fail to produce a true value if it was tested over isDigit. isDigit would just say if it was an integer or not, if the entire string is comprised of all digits. Now clearly this string is not entirely digits. It has a dot in it. Dot is not a digit. What we could do is that we could say replace that dot temporarily with nothing, only once, and now try to check if the result is a digit or not. In this case, 4.5 or 4 should both produce the true value. Now we are getting what we really wanted, which is the square root of 4.5. We can still get an undefined message if it was a negative number, but this is not the message that we really wanted to receive. This is saying unable to compute the square root, which is this else, because again the negative sign is not an indicator of all digits here. We could replace that, or we could just use this excuse here so that we can forget about this else here, which is in this case, if any negative number comes up, we'll just go ahead with this else. So we will not need this else anymore here. So any negative number will just fail to produce a true here, and then go to the else part, which is what we want ultimately. Now this is a simple application of using conditionals in Python. We could use another way of conditionals, which is having more than one condition in our statement. Let's take another application here. We could go ahead and create a new file. Now here we want to receive a grade from the user. Let's call it grade. We'll just assume that the grade is always something that can be evaluated to a numeric value. Otherwise, we'll have to do all this checking again here. Now we want to map that grade, which is a number out of 100, to A's and B's and C's and D's. Let's assume that an A is always 93 or above. we could say that if grade is greater than or equal to 93, print A. Now this part is easy, it's just an if statement and it will work flawlessly. We can try that. So if it was 93, we'll get an A. If it was 95, we'll also get an A. If it was 90, we'll not get anything because the program has no way of telling what to do with any value less than 93. We could say that if the grade was between 90 and 93, that is an A minus. So we could specify this and this condition, and this is going to be an A minus. So let's try this one. Here we have again 93 working like before. Now if we get a 92.5, that is an A minus. And again, if something goes beyond the conditions that we have specified for the computer, we'll just get nothing. We can go ahead and specify another range, which is if the grade is between, say, 87 and less than 90, that would be a B plus. Here we can test that again. So if we have 87.2, we get a B plus. If we have 96, we get an A. If we have 91.4, we get an A minus. Now these are three conditions. We can continue with all the ranges that we have and get over with all the letter grades. One problem here is that we cannot just say an else here, because the else here would be only tied to this condition here. So an else is always tied to the previous if statement. We could instead use something called an elif. Elif is an else and an if, meaning that if this condition was not true, the Python interpreter would go ahead and check this condition. So otherwise, if another condition. Now, if this wasn't true, the compiler will go ahead and check this one, and so on. So what we could here say is that if grade is greater than 90, here we can also say that if grade is greater than 87. Now, why don't I need to specify an upper bound here? Because if the grade was greater than or 93, then this statement would be true and we're done with the rest of the conditions. None of these conditions will be looked at. If this was not true, then the grade must be something below 93. So here we're just bounding the grade to the lower bound, which is 90. So if we are checking this condition, we are sure that it's below 93. We want to make sure that it's not below 90. If this was the case, then we have an A minus. So we could say else print an F. Let's try our program. If we have a 93, then we have an A. If we have a 92, we have an A minus. If we have an 88, we have a B plus. If we have an 80, we have an F. Okay, of course we can continue, add more lower bounds here to complete our grade assignment program. Now this is pretty much all we need to do about conditional statements. There are other cases that could be interesting. For example, if we go ahead and check up the control flow page on python.org, we can see that we have some more control statements, including the match statement, which is somehow a pattern matching statement to check different cases of a value.